Hey guys, thanks for joining me for another Ed Puzzle. If you did not print out the notes, I want to make sure that you're going back and looking at the original document before you answer questions today. If you're trying to read it just off the Ed Puzzle video, it might look really small and it might lead you to wrong answers. I cannot go back and change and remark all of your missed answers, so I need you to look at the original document if you are not printing this out. But if you're printing this out, even better. I think it's a lot easier for you to work along with me. All right, so for number one, we are going to find the area of a circle. And we've reviewed that formula. That should be an easy thing, and leave your answer in terms of pi. If you can't find the pi button and how to get that on to your answer, just write the word pi for pi today. All right, go ahead and find the area for number one. All right, well, hopefully you came up with 144 pi inches squared. So when you look at this, you know the formula is pi r squared. You need to know this. This is a very simple formula. Please don't take the SAT and ACT without knowing this. All righty, so we've got the radius is our 12. So we have pi 12 squared, and then we're just going to do 144 pi inches squared is our final answer. So I just wanted to review that real quick, because what we're going to look at today is the sector of the circle. And the sector is not the entire area. It is a portion of the area. And so you can see, here's the definition. It's the region bounded by two radii in their intercepted arc. So when you look at this colored in region here, you've got the intercepted arc PQ, and you've got the radii OP and OG. And so this is a sector. It's just a portion of the circle. So what we're going to do is we're going to actually use the area formula, the pi r squared, but we don't need the entire circle. We're going to use a part of the circle. And so if you think about it, your whole entire circle is 360 degrees. We're going to use whatever portion that they give us. So whatever this little central angle is going to be the same thing as whatever our arc measure, right? That could be your arc measure or your central angle. And that's going to be the portion of the area. So you will do something over 360 times pi r squared. That's the formula that we're going to use for the sector of a circle. So take a look at number two. Number two, I started off with something easy. It gives you 90 degrees. Hopefully you're thinking in your head like, hey, I know that 90 degrees is a quarter of my circle. But you might find that out if you did 90 out of the total 360 times pi, and this one has a radius of 12 squared. So it's the same circle that we had up here in number one. We're just doing a quarter of it now. And when you reduce the 9 over the 36, watch what happens. The zeros cancel, right? And 9 over 36 is 1/4. So that's a quarter of your circle, 1/4. And if you know that 90 degrees is 1/4 of your circle, you can start off with 1/4 instead of doing the 90 over 360. But if this is helping you, the formula, then just do it like this every time. So we've got pi times 12 squared. So we have pi times 144. And I would love just to see you leave your answers as exact as possible. I'm not going to go for any decimals in these. We're going to use pi. And 4 does go into 144. It does 36 times. 36 times 4 is 144. So our final answer here is going to be 36 pi. And this is area. It didn't give us units here on this one, so we're just going to leave it as 36 pi. All right, why don't you go ahead and try number 3. There you go. Try number 3, please. Just finding the area of this sector of the circle, the shaded in region. Okay, did you get 2 pi? All right, so first thing you need to understand is that the radius is 2 feet, right? The whole diameter is 4 feet, so the radius is 2 feet, and we've got half the circle. Now you could do 180 degrees over 360, but that is 1/2 of your circle. And then the formula for area is pi r squared. So we're going to do pi and 2 squared, and these are feet, right? We're going to do feet squared. So we got 180 over 360, which is 1/2. We have the pi, and 2 squared is 4 feet squared. And 2 goes into 4 twice. So we have 2 pi feet squared. That's the area of our sector. Now, if you're taking a test and it asks you to find the decimal approximation or round to the nearest decimal, it will tell you what to use for pi. We're going to keep everything in terms of pi, which means we just stop right here. But on your test that you take, they'll tell you what to put in. Usually it's 3.14 or 22 over 7, or sometimes even the pi button on your calculator. All right, I want you to try number 4 on your own. We're looking at this sector that's 110 degrees. Leave it in terms of pi, please. All right, so hopefully you got 44 pi meters squared. So for this one, we're doing 110 over 360, our total degree measure, times pi, and this is 12 meters squared. Right, so right away, cancel out those zeros. We have 11 over 36 times pi times 144 meters squared. Oops, can't see that, can you? There you go. So how are you going to simplify this one? Well, remember, the pi is over 1 and the 144 is over 1. So 36 and 144, we saw there was a relationship, right? Do you remember I told you 36 times 4 equals 144? I gave you a nice one on purpose. So 36 goes into itself once, and it goes into the 144 4 times. So now we've got all ones in the denominator. We can just forget about the denominator. And we have 11 times 4, or 44 pi m squared, meters squared. All right, so you're going to see some of those in your homework, so be ready with that formula. The second thing that we're going to look at today is part of the circumference. So let's just review. Number 5 is finding the circumference of a circle with a diameter of 10 meters. You do it. All right, hopefully you said 10 pi centimeters. This one's super simple. For the circumference of the circle, and that's just going around the outside. That is the perimeter, right? Perimeter is not area. It is just a unit of length. It's distance around the circle. So you're going to use not square units, but just linear units here. And we've got pi times the diameter is one formula, or you can do 2 pi r if you're working with the radius, but it takes 2 radii to make 1 diameter, so there you go. And in this problem, we know the diameter is 10 centimeters, so it's just 10 pi centimeters is your circumference. All right, so our second topic today goes along with circumference. We are looking at something called arc length, right? And if you recall, you have a minor arc right here, right? If you look at xy, well, one of the ways you can measure the arc is by its degree measurement, right? From the central angle. So this is 70 degrees, but the length is the circumference. So when you think of length, I want you to think of like you would maybe walk a mile, or you would walk 10 feet. It's a linear unit. So think about taking a tape measure and going around the circle, but we're only going around this little section of the circle. So since we're only doing part of the circle, the formula for the arc length is going to be, let's just write this out, arc length is going to equal the degree measured, so the ours is 70 out of 360 times the circumference, pi d. All right, so in this problem, we've got 7 over 360 because the zeros will, over 36, the zeros cancel out, times pi. And the diameter here, if we were to extend this out, right, we have another 10. So the diameter is 20. Now let's see if we can reduce a little bit here. The 36 and the 20 are both divisible by what? Hopefully you're saying 4, right? So 4 goes into 25 times, 4 goes into 36 9 times. So we've got 35 over 9 pi. And I really love for you to leave your answers as simplified fractions because the further along you go in math, the better that's going to be for you working with values. So we're going to leave it like this. All right, and it didn't give us units on this one. Let's try another one together. All right, so this one, number 6, looks a little bit different. But you've got the length. I love this picture because it's showing you the arc length here. And we're looking for that length from A to B. And it gives you the degree measure is 120. So we're going to do 120 out of our 360 degrees, our total. And look at the diameter. The diameter has another 3 inches here. So that is times 6 pi. That's your circumference, right? We're doing the part of the circumference. Now, this one's nice. The zeros cancel, and you should know that 12 times 3 is 36. So this is 1 over 3. So you're really looking at 1/3 times 6 pi. And the 3 goes into the 6 twice. So we've got 2 pi, and we have inches on this one, right? And it's linear, right? We're just doing this little section right here. It's linear, so no squaring. All right, you try number 7, please. Did you get 4 pi? I got 4 pi. All right, so first thing I notice is the degree measure is 60. So we're going to do 60 out of 360 degrees times, this is another 12 over here. This is the diameter of 24 pi for my circumference. Okay, so here we go. Let's knock off the zeros. And 6 over 36 is really 1/6 when we reduce that, times the 24 pi. 6 goes into 24 4 times. So we've got 4 pi, and they didn't give us units. Okay, so hopefully you're feeling confident. You are going to see quite a few of these in your homework, so you'll get to practice. All right, one last skill. I'm going to do a harder one with you. Number 8 is a little bit more difficult than number 9. But this is finding the area of the shaded region. So the shaded region, we are going back to area. And you look at number 8. So we're going back to area. What we're going to do is we're going to do the area of the whole entire sector, and then we're going to subtract out that triangle. So let me write that down. We're going to do the area of the sector, and we're going to subtract out the area of the triangle. So let's walk through both of these, right? The area of the sector is going to be 60 over 360 times our pi r squared. Pi, and it is 8 squared. Now we're going to subtract this from 1/2 base times height. So let's do that sector real quick, and then we'll talk about the triangle. So we've got the zeros canceling. The 6 over the 36 is 1/6, and 8 squared is 64. So we are looking at 64 pi over 6. And we can reduce that, right? They're both divisible by 2. So we've got 32 pi over 3. So that's the area of our sector, and we're going to subtract out the triangle. Now the triangle, when you look at these triangles, remember that the radius is the same. So this is in 8 meters, Now this is a 60-degree angle, so this is a special triangle. But all your triangles are isosceles. This one, since this is 60, this is a 60, 60, 60, or an equilateral triangle. So let me just draw it a little bit bigger right here. We've got 8 meters and 8 meters and 8 meters and 60 and 60 and 60. All right, so we've got the base of our triangle. We need the height. I'm going to draw it in pencil. Here's going to be the height. And so right away, you know that this is 30 degrees up here at the top, right? And this has been bisected, this base. So we have 4 meters on this side and 4 meters on this side. Well, you could do this two different ways. You could remember your 30, 60, 90 right triangles, or you could do Pythagorean theorem. I'm going to choose to do 30, 60, 90 right triangles. So if this is my smaller leg, it's 4. My longer leg, do you remember, is 4 square root of 3. So that's the height of my triangle. So I'm going to do minus 1/2. The base is 8 meters, and the height is 4 square root of 3. So let's figure out what that gives us. So we've got 1/2 of 8 is 4, and 4 times 4 is 16. So it's minus 16 square root of 3. Now I'm going to tell you right now, that's a great answer. You can leave your answer like that all day long, and I'm super happy with it. Okay, so there we go. Even the answer. Okay, now number 9 is easier because the triangle is nicer. So look at what it's giving you and go ahead and find the area of the shaded region. All right, did you get, what did I get for this one? 25 pi minus 50. 25 pi minus 50. Let's take a look at this guy. So you've got your 90-degree angle here, right? So you know it's a quarter of a circle. And you've got one radius is 10, you know this other radius is 10. And this triangle is way nicer because that's your base and your height, right? You don't have to figure it out like we did in number 8. So we're going to do the area of the sector minus the area of the triangle. And so our sector is 90 over 360 times pi and the radius squared. So let's see, we've got 1/4 times pi times 100. And 100 divided by 4 is 25 pi. Yay. Now the area of the triangle, minus 1/2, a base of 10, and a height of 10. So we're really doing, we could do just half of one of these 10s is 5, and 5 times 10 is 50. So we're just subtracting 50. Now you can leave your answer like this. That's a perfectly great answer. Okay, that's it. Have a great day. Thanks for doing math with me.